The destination IP is still this host C. That is the address. But the source IP was changed to 200.10.10.1. This is a public network. Internal future host B wants to go online. Then this 192.168.1.2 needs to access host C on the public network. The destination address remains the same. But here we need to consume another public network address. This is for 10.2. These are the two public IPs. It is equivalent to the current 10.2 mapped from 1.2 to the public network inside the host. Then go to communicate with host C. Then host C will reply the data packet in the future. It must be replying to the destination IP. Sent on 200.10.10.1. The purpose must be 200.10.10.1. It will now reply to 200.10.10.1. Source is itself. After the packet comes back. On this device. Just had a map entry like this. Converted from 192.168.1.1 and this 200.10.10.1. So it will now change the destination IP to the IP of my host A. Then send it back to host A. This is also the same. Actually, static NAT is a binding relationship. That is, we need to artificially make a binding. It feels the same as configuring static routing. We're going to do a static binding. Put such a public network address. The only one tied to this private network address. Only for it to use. The advantage of this is, I only need to go online in the future. You must be able to take this public network address. But the downside is that once I do the static NAT binding. For example, now I put this address of 200.10.10.1. Bind to this 192.168.1.1. Then even if 192.168.1.1 does not go online in the future, this address cannot be used by others. It does not have the concept of an address release. It will not be released. It doesn't. No one else can use it. Let's see what this static means. We do a basic configuration. When we configure, first of all, the equipment must be changed. These two PCs are simulated by routers. Because we will talk about a server on the internet later. So use a router. I'm done naming. But I don't remember how many configurations I made. I have already configured the address. Show interface brief. Okay. I did configure the addresses. Because today's class time is quite tight. I have configured the address. After I finish this, save this configuration first. Then let's start. How do we take a router to emulate a PC? I don't do other configuration now. Just configure an address for it. It is okay to use a router to simulate a PC. Then we have to turn off the routing function of this router first. No IP routing. We turn off its routing function. Secondly, we configure a default gateway for it. 192.168.1.1 is the address of this interface. I will write it. This is the current gateway. I put it here. This is the gateway interface. 192.168.1.1. Two PCs are on the same network segment. That's it. Then type write. You can save this configuration. We will use this configuration again and again later. So I just saved. Just to show you guys the command. I also enter no IP routing here. IP default gateway. 192.168.1.1. Manually configure the gateway. It's like a PC. I manually configured a gateway for the PC. The address is configured for the PC interface. Turn off its routing function. It's a PC now. As a router, you turned off its routing function. Then it is no longer a router. It's a PC. I configure a gateway for it. In the future, it will go to the gateway across network segments. So it really is a PC now. But we can configure some commands for it here. For example, I can let it be managed remotely. We just facilitate future configuration. So let's take a router simulation here. This is the basic configuration of two PCs. What I want to achieve now is, I hope this PC1 can access the internet. If PC1 can access the internet, we only speak from the point of view of configuration. How should we configure it? PC1 is now across network segments. Find gateways across network segments. Then the gateway only needs to have a route to 8.8. Since this is the operator, often the exit is a default pointing outward. Logically speaking, this address on the public network will not reply packets to the private network. We have a plan. From a configuration point of view only. Of course I can write a link here to 192.168.1.0. Dump traffic to the gateway. Gateway is directly connected. Just send it here. But what we're talking about today is, we want to access the extranet. For the public network, it will not write a static point to the internal private address segment. We cannot perform corresponding routing configuration on this device today. We are going to implement PC1 internet access. And the ISP passes it back. Which is equivalent to, there is no route to 192.168.1.0 in it. Then it needs to communicate with PC1 through other means. First send the traffic to the gateway. This is our need. Let PC1 go online first. We are also like this in reality. The gateway must first have a static route pointing to the operator. The operator will not have a static point to our. But we want the route to point to it. IP route 0.0.0.0 0.0.0.0. The next hop is 100.1.1.2. After pointing out, the data can go out anyway. But does the data come back? We have to do static NAT on the gateway. Let's take a look. Let's open this first now. After opening, let's ping the PC first. Can you guess if this data packet from the PC can be sent out? I visit this 8.8. I have already configured the address in the operator. Can I get the data packets sent by PC1 under this interface? Let's ping here. Ping 8.8.8.8. First of all, we don't care if it works or not. Can I get the packet? Let's take a look. Now the data seems to be out. Did you discover it? We get the packets here at the operator. The packets I get under this interface. The obtained data packets can be clearly seen. Now there is a 110 sending data to 8.8. But 8.8 didn't return it. So it doesn't work now. That is, when the data goes out now. Since it is a private network address, there is no private network route on the public network. So it can't communicate. We have to configure it to come back. Do NAT on the gateway. We make a static binding for it. So the premise we are doing this must be, make sure the gateway and PC are able to communicate. It must work. Because the packets are out. So we are now doing static NAT mapping. In Cisco, no matter what kind of NAT you do, there is a command that must be entered. IP NAT inside source. No matter what NAT configuration you do, this command is necessary. This is a fixed configuration. We now do static configuration. I enter a question mark. There are 3 types. We use this static today. The route map is called the strategy level. UNP will learn it. This list we'll see later. Let's look at this static first. Enter a question mark after. Inside local IP address will appear here. That is. Now you can enter whoever you want to access the internet. I want this 192.168.1.10 to go online now. I just type 1.10. Enter another question mark. Then, inside global IP address, appeared again. For example, the network segment that is now connected to the operator is the 100.1.1.0 network segment. Suppose I have an address 100.1.1.3. Assuming this address is what I bought from the carrier. This address must be directly connected to the operator. Must be in a network segment. Otherwise, there is no way to use it directly. We can't just make up this one. Because this address is not given to you by the operator. If you configure this externally, over there is not acceptable. So, the public network address is not something we can use casually. If you use it indiscriminately, no one will use PPPoE. We also don't have so much technology. Everyone can use whatever they want. Then it is no different from private network. Addresses running on the public network cannot conflict. 100.1.1.3. I hit enter. I have now entered a static NAT. I mapped the internal 1.10 to the external address I bought.